inside the nose, and it helps to purify or humidify the air, and it also stops dust particles from entering our nose. And the tiny hairs called inside the nose called cilia help move the nose so it can be sneezed out or blown out. Um, the epiglottis is just above our bronchus, and it helps and it stops food from entering our lungs from when we swallow. So that it blocks up the pathway, so it can then go down our esophagus, so our lungs don't become blocked up. And the next is the pharynx, and the pharynx um is a provide is a both food and an air pathway, and before reaching either the lungs or the stomach, it helps to divide it. So just as I said before, it doesn't get blocked up. It also helps to play a role in our speech as it's near the um epiglottis or the voice box. The larynx is essential for human speech as it gives us, as the rigid walls helps to define our different and individual types of voices. Just below the larynx is the trachea, and it's the main airway to the lungs, and it transports either carbon dioxide. It transports either carbon dioxide and oxygen, so it can get through our lungs to our bronchioles and bronchus. The bronchus is just below the trachea, and it helps um and it's just below our trachea, and it helps the oxygen to be split into our left and right lung from the trachea to the bronchus to the bronchioles. The bronchioles is the separation of the bronchus, and it splits into the left and the right lung, which then allows our oxygen to be diffused into more than one lung, which makes it more efficient. The lobes, our lungs is um our oxygen comes from, and it helps to the lungs help to oxygenate blood and make it useful for our body, and it also helps to get rid of carbon dioxide, which is a waste product. And um yeah our lungs have our right lung has three lobes, and our left lung has two lobes. The lobes are there so that if one lobe gets infected, it doesn't affect the whole lung, and rather it only affects that one lobe, so that the rest of the lung is able to function without being infected, but just because of one disease from one lobe. The pleural mem the pleural membrane helps keep the lungs together, and the pleural fluid allows the lungs to be lubricated, so there's less friction during respiratory functions and actions. The parietal pleura is the outermost layer of the lung and covers the internal surface of the thoracic cavity. It is sensitive to pressure, pain, and temperature, and it provides a well localized pain and is innervated by the phrenic and intercostal nerves. The visceral pleura, gives a smooth, slippery surface to the lung, which allows it to move freely during the in the parietal pleura. The alveoli in the lungs are small little air sacs which allow gaseous exchange to take place. Gaseous exchange is the exchange of oxygen in the alveoli, where the where oxygen become where blood becomes oxygenated in the alveoli, and it releases carbon dioxide, which then comes out through the lungs, which is when we breathe out. The diaphragm is the muscle that helps lift up the lung, which allow it to push out carbon dioxide and take in more oxygen when we breathe in and out. The intercostal muscles, the internal intercostal muscles lie inside the rib cage, and they bring the ribs down and decreasing the volume of the chest cavity. and forcing air out, and the external intercostals outside the rib cage, um they pull the ribs down and therefore and decrease the lung volume out of the chest cavity, drawing air into the lungs, which help us breathe in and out. Gas exchange is the delivery of oxygen from the lungs to the bloodstream and the elimination of carbon dioxide from the bloodstream of the lungs. To the lungs. It occurs between the alveoli and the blood vessels where the deoxygenated blood then releases out carbon dioxide, and then and oxygen inside the alveoli is then diffused into the um blood blood cell through the capillary, which then makes the blood oxygenated. Tidal volume is the volume of oxygen that leaves and enters with each normal breath. And inspiratory reserve volume is the extra volume that can be breathed in above tidal volume, from normal quiet inspiration to the maximum inspiration. Expiratory reserve volume is the extra volume that can be breathed out below tidal volume, which is that's when during tidal volume we breathe out as much as possible to our maximum expiration. Residual volume is the volume remaining after our after our maximum expiratory reserve volume. Our vital capacity is the maximum amount of oxygen that can be breathed in one breath, and our our inspiratory capacity is the volume breathed in from quiet expiration to our maximum inspiration. Our functional residual capacity is the volume remaining after quiet expiration, and the total lung capacity is the maximum amount our lungs maximum amount of oxygen our lungs can carry in one breath or one exhalation. For control of breathing, there is neural and chemical control. Neural control consists of our phrenic and intercostal nerves. These two nerves regulate the activity of the respiratory muscles and the diaphragm and external intercostal muscles. And for chemical control, the most important factors modify respiratory and depth are chemical. The levels of carbon dioxide inside the levels of carbon dioxide and oxygen in the blood inside our blood will affect how the chemical factors will change the levels of acidity in our blood. For example, if there was too much lactic acid in our blood, then the chemical control will then tell the heart to tell us to start breathing more quickly, so we can get more lactic acid out of our system and also carbon dioxide out. And if there wasn't enough oxygen, it will also tell us to breathe faster and quicker, so we can breathe, so we can get more oxygen into our system.